Hello again, everyone. This is the second video in our series on light chasing kind of projects on the Arduino. So what I want to do in this lesson is, before we go on to a new project, I want to change our project code to where it's more usable, more easy to edit, and hopefully more easy to read. But in order to do that, I'm going to have to teach you a little bit of different coding ideas. So let's take a look at the code that we wrote in the first lesson. For now, I'm going to get rid of this delay 1 because I just put that in there because sometimes adding that little delay 1 helps this simulator work better. You shouldn't need that in your actual code. Okay, so there's a rule of thumb that I always go by in programming, and I talk about a lot. I read it many years ago, called dry programming. It means don't repeat yourself. This is important for many reasons. Repeating yourself means that if you have one little typo in your code and you repeat it over and over and over again, like using cut and paste, then you've just copy and pasted the error code all over the place. And now it's going to be a real trouble to find it and fix all of those different places. That's one reason why we don't like to repeat ourselves. Another reason why is it is very slow to read. It's difficult on the eyes. And one more reason why you don't want to repeat yourself in coding is that when you have to be able to make changes, or if you want to redo and make things happen more than once, then you have to go in and do it all over again. And so a lot of the stuff I want to do with this array of LEDs that we've created for the last project, it'd just be really difficult to do with all this repetition. So the first repetition that I am going to get rid of is this pin mode. And I'm going to do that with what's called a while loop. And so in order to use a while loop, I need to make a variable, and this variable will be used in making our loop know where to start and when to stop. So this loop is kind of similar to the function loop in that it's gonna be a block of code that goes over and over again, but it's going to be inside of this setup function. So in line 2, we're going to create a variable, and this variable is going to be a number that goes from 3 all the way to 13, because I want to get rid of all of this line of code. And what I want to do is, instead of having all that, I want to have this number here change one at a time. And if you notice, that's the only thing that changes in lines 3 through 13 is that number. So we really should not have had to put all that stuff there. We should have been able to just leave that at 3 and make that a 4, 5, 6, 7, 8, and then 9, and then 10, 11, 12, and 13. So what I really want to do is I want to make a variable, and we're going to call it x. And I want that x to start at the number 3 and end at the number 13. So when you create a variable, it would be nice if I could just say, x is assigned. The equal sign means assigned to 3. Unfortunately, this does not work in the Arduino programming language. Your Arduino needs to know what kind of numbers you want to put in the variable x. So do we want to put numbers that are like whole numbers or integers, right? As they called integer, or do we want to have real numbers, numbers that are decimals, like pi is 3.14 approximately. Those are called floating points. So we're going to be counting 3, 4, 5, 6, 7, 8, 9, 10, etc. Those are whole numbers, or in math we call them integers, right? So we're going to be using integers, and we're just going to abbreviate with the word int. You'll notice how it turned it purple here. It is just indicating that that's a special word. and I'm going to put a semicolon at the end. Now, this equal sign, I want you to understand, it's an assignment. It means I am assigning, and it goes from from right to left. So I always wish that there had been something like that, like an arrow showing that this 3 gets shoved into the x. But this is the tradition that we have stuck with in computer science, that the equal sign is the assignment operator. So I like to read it as x gets 3. So the 3 is put into the x, okay? All right, and now I need to make a loop. And so what I'm going to do is I'm going to say while, and then inside here I need to put in a condition, okay? And I'm just going to leave that blank for now, okay? So that needs to be a condition that will be checked every time. And I take this and I'll just take it out and put it there, okay? All right, so what we need to think of is, well, what do we want to do? How long do I want this pin mode, this line 4? Notice line 4 is the only one inside these curly brackets. This is the code line because it's inside these curly braces of the while loop. That's the code that's going to go over and over and over and over again. Okay, so I need to put in a statement here that tells it when to keep going. So the while loop can be thought of as I'm telling Arduino, I want you to keep doing line 4 over and over and over again while this statement is true. And the statement I'm going to put in there is that x is less than or equal to 13. So by saying while x is less than or equal to 13, I know now that when the x value is not less than or equal to 13, the Arduino will no longer keep doing this line of code. So x will start at 3, and when x is 3, that's what we put right there, the number 3, and we'll set pin mode 3 to output. Okay? All right, now as it stands right now though, that x is not changing. So the x is going to be a 3, and then the Arduino will check the while statement. It'll say, well, is x less than or equal to 13? Well, yeah, 3 is less than or equal to 13. So then it's going to try again to set pin mode 3 to output. Well, we've already set pin mode 3 to output. I want to set pin 4. So I need to change this. And let's go over 3 different ways that Arduino allows us to increase the value of x by 1. I can say x is equal to x plus 1. All right, well, this is not an algebra equation. I'm not trying to solve this for x, and this would probably not make much sense in a math class, but in computer science class, what I'm saying is that x gets a new value of itself plus 1. So whatever x is when we come to line 5, we're going to change x to a new value that's one more what it used to be. And so I think it's worthwhile to talk about the order in which this statement is evaluated. This assignment operator, the gets, if you will, always comes last in the order of operations. So what we're going to do is we're going to do this part of the code first. So we're going to take, when we start, the first time we go through this while loop, x is 3. It'll actually check, is 3 less than or equal to 13? Yes, it is. It'll set pin mode 3 to output. And then what's going to happen is this is going to become, that I've highlighted, it will become 3 plus 1. That's 4. So then x gets 4. Okay, so now that's good. We've changed x value. After the Arduino running the code gets all the way done with line 5, it reaches this curly brace. That tells it to go back to the top. But it's not going to do that until it makes sure this is still true. Well, now x is 4. So is 4 less than or equal to 13? Sure is. That means I get to keep going. Then it'll be pin mode 4 is an output. Great. That's exactly what I want to do. I want to set pin mode 4 to an output. Then x will get the value of 4 plus 1. 4 plus 1 is 5, making x 5. So then it would continue now because 5 is less than or equal to 13 and set pin 5 to output. Well, this is going to continue all the way down until, when x is 12, it'll set pin 12 to output. Then 12 plus 1 is 13. X is equal to 13. Comes back up here and checks. 13 is less than or equal to 13 because it's equal to it. And it'll set pin mode 13 to output. Remember, it does this side first. 13 plus 1 is 14, so x gets 14 now. Well, now it comes up here and checks, and 14 is not less than or equal to 13. That is a false statement, right? Because that's a false statement, the while loop will no longer continue running, and it will now come to the first line of code after this curly brace, which just in this case happens to be the curly brace ending our setup function. All right, so let's just run the simulation right quick to make sure that everything is still working as it was before. As you can see, the lights are starting at the right and chasing after each other as they zoom over to the left. And hopefully you've played around with this some and changed these delay values, so we can make different lights stay on different amounts of time and so forth. But for right now, I just left them at the 100. All right, before we go any further, I need to discuss the other two ways that you can change your x value. This statement here is so common in computer programming that we're given a shortcut. We can change this to x plus equals 1. What that means is take x, add 1 to it, and store it back in itself. The computer reads this as x equals x plus 1. That's exactly what plus equals means. It's just that it's a little bit shorter. I like x plus equals 1. It shows a clear increase by 1. It makes a lot of sense. Notice the plus has to come before the equal sign. Likewise, there's pretty much one for all the operations. If we wanted to change x by x minus 1, we could use minus equals. Okay, got a little bit of trouble here with the, there it is. Was not responding there for a second. Okay, so we could, there's a x equals x minus 1, that's minus equals, there's even a, if you're multiplying it, I know multiplying by 1 wouldn't do anything, but you could times equals by 2 and it'll double every time. There's a divide equals, there's even a mod equals if you're familiar with modulo. All right, so we've got that. There is one other way that we can change the x value. This can be done if you want to increase or decrease by 1. You are allowed to use the variable x and then plus plus. So plus plus will automatically increase by 1, and then also minus minus will decrease by 1. It is a controversial operator. Some of the more modern programming languages, Python comes to mind, do not allow the x plus plus operator because it tends to be difficult on the eyes to read, and then some people kind of misuse it, and it can cause some headaches because it's not always obvious what's happening, and we like to have things obvious when we read code. So my rule, if you want to use x plus plus, go for it, but always keep it on a separate line. Don't try and mix a plus plus into another line of code. That's a disaster waiting to happen. All right, so there we go. We've got a while loop here, and it works like we want it to. Now let's look at this loop here. Now this loop, I hope you notice this was a pain to write. And I mean, my eyes are watering just trying to look at this stuff. And again, same issue though. Each one of these little triplets of code here has exactly the same thing. It's just one number that's changing. Well, let's use a loop to do that. But I'm going to use a different kind of loop, okay? So I'm going to continue with the same idea I did before, okay? Right here. I'm going to use the variable, let's use the variable x again, okay? Since our x variable is declared. We created it here inside the setup function. We can use X again down here without any confusion. All right, so I'm going to use a different kind of loop, though. I'm going to use what's called a for loop. So let's learn about that. There are others, there's kinds of loops, but for and while are the two that you really want to know. So let me just go ahead and write it out for you, and then I'll take it down piece by piece and explain it. All right, there's the body of it. And what is it that I want to keep doing over and over and over again? I want to keep doing those lines right there. All right, so you know what to expect here. It should be exactly like the previous loop. We should have X start at 3 so that we write 3 high, delay, then write 3 low. Then we need X to become 4 so that we write 4 to high and then delay and then write 4 to low. Remember, high turns on the light, low turns it off. And we need it to continue all the way up through 13. So let's understand how this works. The for loop can be thought of as reading, do this code for as long as this is true. So this middle part is what is going to be checked. It was like the while condition. So there are 3 parts to creating a for loop. In the parentheses, you have to create a variable, you have to check a variable, and you have to change a variable. Create, check, change. So first we create the variable X, and I give it a starting value of 3. Then we have our check condition that we check the continued loop while X is less than or equal to 13. And finally, we tell X how to change. I can use X plus equals 1 or simply X plus plus. I'll go ahead and use the X plus plus here for variety. If I wanted to change the X by 2, I would use X plus equals 2. Maybe if I wanted to skip lights or something like that. So I do think it's important to take note that this little block of code, when the for loop is entered, will be run only one time. We only want to create X equal to 3 at the very start before we start looping. Otherwise, we'd be at 3 every time, right? So this code is run only once. Then, after that code is run, the loop process begins. Before it enters the loop, it checks this condition. So if I said let X equal, 14, none of this code would actually happen at all, because it would let X equal 14 and then say, okay, well, X is not less than or equal to 13, so I won't do anything. But no, we want to start at 3. So it's going to check this every time before it runs these lines of code. After running those lines of code, then is when it increases the X value. Right? So because I want it to be 3 the first time it goes through. I don't want it to change to 4 until afterwards. So it will wait until afterwards. Let's go ahead and check out our simulation now. And there you go. Practice writing your own for loops and while loops. And you can check it very easily to see how this works by giving it different pin numbers. Say I want to start at 7 and practice going only to 12. Also, practice using a while loop here instead. Now, we want to make sure you turn everything on to output, but you could practice using a for loop that goes from 3 to 13 to set all the pins to output. Just a quick note, the reason why this loop is going over and over and over again is I have a loop within the function loop. So it does my loop to turn on all the lights 7 through 12. When it's done, Arduino will call it again. Remember, the loop function is called by Arduino over and over and over again, and that's why I see it going over and over and over again. All right, well, that's it for this lesson on looping and data structures. Well, not data structure, excuse me. Looping and process control, flow control is what we call that. We'll get the data structures later. That's it for that, and I'll see you next time.